Hello, I'm Jack Rickard with EVTV. It's Friday, the middle of March, and starting to look like spring around here a little bit. Brain has sort of been in and out for the last 3 weeks or a month. I don't know what's going on with him. He's in Louisville this week taking the spirits test, which they had scheduled for the time when we had EvCon last time, so he's missed it once. So he went yesterday to Louisville, and today is taking the whiskey and spirits test to try to become some sort of a muckety-muck about whiskey, leaving me with the EVTV and Cadillac Escalade duties. He did, however, before he got going, get the engine pulled out of the Escalade. And that's quite a task. They did a marvelous job of it, tagging each of our sensors and wires on our harness here. Got our heater hoses here where we can splice in for heat or air conditioning, transmission coolant lines. And here is the face of our 6L80 transmission. We right now have our two 11-inch motors on a single shaft connected to a 4L80E transmission, which is almost identical in the housing. We have three bolt holes here on the torque converter. Two, I think, on the other one, but we'll make those adjustments. What we found very encouraging is that sometimes it's better to be lucky than good. Our motor, from the face of the adapter plate to the transmission to the very tip of really the air conditioning compressor mounted on the front of the motor, represents our total length, which is 35.5 inches. Our distance from the face of the transmission in the vehicle to this front cross member is actually about 37.5 inches, and the distance to a brake line that goes across there is about 36.5 inches. And so our 35.5 inches total length is going to fit within our frame and everything just perfectly. Our radiator and so forth would normally be here. Now there were some fans to the inside of that we're gonna have to lose, but the basic coolers and so forth up here, we're going to have more than adequate distance to accommodate the entire motor. The motor itself stands about 3 inches in from the edges of this, and so should clear everything. There is a little kink here in a line to our rack and pinion steering that could potentially pose our closest point to the motor, but I just don't think it's going to be a difficulty. Our engine mounts go here and here, which is conveniently about, not exactly, but about midway between our two mounting holes on each side for the motor. And so we should be able to fashion some sort of a crossbar to that standard mounting connection here. That will actually mount the whole motor assembly to the same place that our Cadillac motor was mounted to, and that be reasonably a midpoint, and that'll keep the motor from turning along its axis and support it vertically. Hopefully we'll work in some sort of an adjustment there where we can tweak it up and down and adjust the angle of our drivetrain you want the angle of that transmission and drive shaft to be the same as the original. And you can get into some things with resonant frequencies and so forth there that can be unpleasant. It'd be nice to have a screw level adjustment to tweak that up and down just a little bit to smooth that out if necessary later on. Of course, our whole motor is not going to be any higher than this, really, coming out here. And so we're going to have a huge amount of room up here on the firewall for various items. And of course, for example, our two Soliton 1 controllers. And so the front, we've got largely disassembled, the engine removed, and we're able to check some basic measurements, and what we're finding there is very, very encouraging. We have adequate room, not plenty of room, but adequate room for everything we want to do in the front of this vehicle. And our original projection of taking two 11-inch motors and putting them together on a single shaft for this automatic transmission is working out very well. Our precautions, for example, removing the two fans to minimize the length of that combined motor and using external blowers, which we were going to do anyway, it has proven brilliant. That inch or inch and a half is exactly what we needed. And we weren't really able to do the actual measurements very closely because all the stuff in position at the time. But that's what I say, it's probably better to be lucky than to be good. So the front of the Cadillac, we've removed the hood, the engine, all the coolants, the front clip, and we're here where we can gain access to it. We have blown our lift up, and Brian sent one of our hydraulic cylinders to Dexter to be rebuilt. It's a little frightening. This is a 11,000-pound lift, and we have an awful lot of truck on it. I've been a little leery about getting under this thing. We're going to have to keep an eye on that. Fortunately, it does have safety latches and so forth whenever we jack it around, but he did blow a hydraulic cylinder somewhere along the way, and so we're going to have that rebuilt. Let's, this is, of course, put us in mind to take a second look at our two motors that are on the, we're going to put in the Escalade, and the two controllers. And we want as much of that working and operational out of the vehicle as we can to minimize the amount of troubleshooting we have to do while we're in here. So a year ago, we built a test bench to demonstrate some of our thinking, this being particularly an automatic transmission adventure, and it worked pretty well. But it's been a year. We've cannibalized that bench several different ways, and are now trying to get it back together. And of course, all the software, the controllers and stuff has been upgraded, and so we have to go through the process there again. Let's take a look at what we're doing there. Here we are at our test bench. This is where we have assembled a mounting system with our two 11-inch motors, an adapter, our transmission. That's kind of the backup transmission for this project. It's made by TCI, and it's kind of a super endowed 4L80E that's pumped up to do 6 gears and manual shifting and a tunable controller. We want to use the transmission that's in the vehicle, the 6L80E, if we can pull that off. And there's a number of aspects to that. We're doing, I would say, everything possible that we could do wrong on an electric vehicle on this particular build, which is kind of why we're doing it and why my fascination with it. Everybody knows that in doing an electric car, you do a small, lightweight vehicle that doesn't take much energy to accelerate and to drive around. We're doing a vehicle whose empty weight, not curb weight or gross weight, but whose empty weight is 5,800 pounds normally. It's an enormous, one of the largest pickup trucks that you could buy, and overweight from huge plush seats, air conditioning systems, and so forth, the various luxury items. But it's a very safe vehicle. It feels big and safe. You have to sit up high and have excellent visibility. And so we wanted to do that. The second thing that everyone who does electric vehicles knows is that anyone who has any cognizance of how to build an electric car, the first thing they do is select an AC, three-phase, polyphase motor drive system, because it has the inherent advantage of regenerative braking. Regenerative braking also implies a direct drive system. Modern, large, heavy cars use an automatic transmission, which of course is big, heavy, and inefficient, and you want to get that out of the vehicle right away. And so you wind up with a dramatically altered vehicle. We're doing conversions, and we have some other criteria, and we're working backwards from what we want the end effect to be. And this leads us to some surprising design choices that are kind of inverted, that I think might lead to some very interesting areas. I said from the beginning that the main criteria is, of course, that the air conditioning and heating work properly on this vehicle. And that sounds a little facetious. It actually isn't. They're a big deal on electric vehicles. And one of the reasons for doing this car was to have a wintertime and summertime vehicle. In the spring and fall, I love the little speedsters, but in February and July, the temperatures here in Missouri cause me to suffer. I need an environmentally enclosed transportation system, and ergo the Escalade. We've looked at air conditioning systems. They're somewhat problematical when they're driven by the pack. We've tried the Mastercraft and some others from China, where you have yet another, a whole drivetrain, a controller, and a motor to drive the air conditioning compressor from the pack voltage. This is a lot of complexity, and it's something that the existing vehicles already do quite well and quite silently with the motor-driven compressors. The problem is that when you pull up to a stoplight, you have to shut down the drive for the compressor, and so you're not really running your air conditioner. That's not a huge problem. People make that out to be a real killer. It's not. You can always put it neutral and blip the electric motor if you're getting warm, but more importantly, your compressor doesn't really run all the time anyway. It cycles on and off as the demands of the air conditioning dictate. The transmission is kind of an issue. How do you move a 5,800 pound vehicle? Even the Tesla Roadster at 2,600 pounds, when they put a 200 kilowatt AC motor on it, they originally had a 2-speed transmission, but of course it tore the transmission out of the vehicle immediately. They blamed the supplier. The supplier was accustomed to building transmissions for gasoline engines. Gasoline engines take 500 or 600 milliseconds to spool up, while electric motors take 5 or 6 milliseconds to spool up. And that difference in time zone puts an extraordinary strain on drivetrain components. We think that there's some advantage in the hydraulically connected automatic transmission using a torque converter. Torque converters have various uses in the ICE world, but we think they may provide an almost ideal buffer for this time difference in reducing shocks along a drivetrain when dealing with a large-scale system. And so we've eschewed the more popular concepts of in-wheel drive motors or direct drive units, which give up a lot of leverage. You have to have a big motor to move a 5,800-pound vehicle with a direct drive. With a 6-speed transmission, we can have a much smaller system to do that. What we've used is two 11-inch Warfield motors, the net gain design, of course, spliced together on one 4-inch shaft that is mated to the flex plate that would go to an automatic transmission with an adapter that fits to the automatic transmission. With an automatic transmission, there is no regenerative braking. That's not possible. And so the advantage of the AC system goes away. We get much higher power for much less money using the DC series motor and controllers. And so in many ways, this sort of reverts to putting the older series DC motor technology back into position as actually an advantage over the very expensive AC induction motor drivetrains. An 11-inch motor from NetGain, I think, is about $3,500. So we have $7,000 worth of them hooked up here. Probably with the additional work, you're looking at about a $10,000 motor. We're going to use two Soliton 1 controllers, and they're each about $3,200 list price, I think. So that's $6,400. So we're at $16,000 or $17,000 in theory on a drivetrain that a UQM, even 150 kilowatt system would be $34,000, and we'll be able to do 2,000 amps at probably 175 volts, so 350 kilowatts here with this system. But it won't have regenerative braking, which is okay because we're going to use an automatic transmission. And so that was some of the original design choices that we faced. One of the things that we have to do to get that transmission to work is get the engine control unit to believe that there's a motor turning. This is the Cadillac Escalade reluctor ring, and this is the crankshaft position sensor. And what this is a 58 tooth, I think, wheel here, and this is a little pulse counter that sends pulses to the engine control unit. This is normally mounted on the crankshaft inside the engine. And this actually has an O-ring, and it fits into the engine and is sealed around there, and then is connected. We've taken one, not the one off our engine, but a replacement, or they call it a reluctor ring, and had it fastened to the front of a wheel from the power steering unit, and mounted that on the aux shaft of the motor. And this lets us use that aux shaft to drive here on this end with a serpentine belt, our air conditioning compressor, and our power steering hydraulic pump, which in the case of the Escalade is also used to drive our power brakes. And so we have power brakes and steering with no vacuum. It's all done with a hydraulic pump. And this is the key to this. So this wheel attached to our aux shaft drives our auxiliaries, particularly our air conditioning compressor and our power steering and power brake power unit. And so this is this plate and system here. We actually spent $3,600 with Lucian in over-engineering this. I had a young intern, Matt Hauber, who got involved with that design. They redid it about 6 or 8 times, and so I wound up with a pretty big bill from Lucian, but it's a very quality piece of kit on the end here, and it lets us do this. I'm sure you can do this for much less, but this is an idler arm that actually is used on the Cadillac, and this is another little wheel that is used on the Cadillac, and we've incorporated those. And so when the motor turns, it drives these units, but it also passes this reluctor ring to give the thing. One problem with that is we don't really have a way to take a standard tach signal off this end of the motor, and so we've had to install one elsewhere to feed our Soliton 1 controllers. And let's take a look at how we did that. Here we are on the back side of the moon here. Here's our motor. And this is our connections here. You can see we've got 2 full sets. This is really 2 motors that have simply been joined on one shaft. And we are going to drive the motors actually separately with 2 different controllers. This is our 2 Garrett superchargers. These will put out about 435 cubic feet per minute, about 3 psi of cooling air. And there used to be a Garrett turbocharger that a guy at XS Turbos takes and puts a little electric motor on it, a little 12-volt electric motor, and drives them as a sort of a supercharger kit. They're actually quite pricey, about $350 a piece, but we like them. They look cool, and they put out a lot of air for their size and for the amount of current you put in them. This is a Cherry Systems NPN open collector magnetic pickup. It'll pick up the passage of the south pole of a magnet. And on our flex plate, on the connecting bolts, we have attached with just some epoxy, some little ring magnets. They're just common ring magnets you can buy on eBay. And it doesn't matter what size or what anything. What does matter is the polarity. You want the south pole facing out. We checked that with an oscilloscope, and by putting the magnets on a drill and turning them and holding this device here. This is a 3-wire device. It takes 12 volts and ground and outputs a pulse when the signal passes. As it's an NPN open collector device, it would normally use about a 2.5 kilo ohm pull-up resistor between the 12 volts and the signal out. You can run it from 5 volts just as well, and it takes a 1K pull-up resistor to the 5 volt supply to do the same thing, and it makes a nice pulse each time it passes one of those magnets. So as our flex plate rotates, the way Brian's got this mounted in here in a hole, right as close to the motor as he could get, it causes this to output a pulse, and we need that pulse as a tachometer input to our Silicon 1 controllers. And we'll talk a little bit about why that is here in a minute, because it's got some neat features. I would point out that we're mounted with some 1/2-inch bolts here, midpoint in each motor. Our engine mounts that I was showing you on the Escalade fall 13 inches in from here, which is right about here, sort of between the 2 motors. We would fashion a bar that went this distance and had these bolts into the side of the motor and then connected here somewhere to the engine mounts. And we're going to have to do some further work on that. I suppose it's normal that we do some news bits. Normally we talk back and forth between the 2 of us. I guess I'll talk to myself and to you. Since last week, what was interesting, we were talking about the Chevrolet Volt and the problems that they had in the interim. Actually that afternoon, they announced they were shutting down the Volt assembly line in Havtrack, Michigan for the period March 19th to April 23rd, and laying off 130 employees, I think. 130 salaried employees, nearly 1,000 workers. And so this is kind of an interesting play. General Motors, of course, avows that they're not abandoning the Volt, they're simply adjusting inventory. And they're talking about basically wanting to avoid the excesses of the past, where they wound up with inventory they had to dump, i.e. discount the price of the vehicles, which they don't like to do, and that made life for them as a company difficult. I'm sure it does. This isn't making life for their employees very pleasant either, laying them off, but apparently this 5-week layoff will let them adjust their inventory to their sales. Well, I think it brings rise the expectation that there may not be any more sales, and so the thing becomes kind of a self-fulfilling prophecy of doom. They have complained that they did not design the car to become a political football in Washington, which is more or less what it has become. The world of OEM electric cars, and understand we're big proponents of electric cars and would love for there to be many to pick from, to just go buy and not have to build your own entirely as a forced option. I think it's a pleasant hobby and an interesting option, but it should be an option, not your only choice, which is where we've been in the years past. But it's kind of becoming a surreal situation. Fisker, who has made 238 vehicles, sold one of them to Consumer Reports. Consumer Reports buys 80 vehicles a year and tests them and reports on them. They've been doing it for many years, a very respected testing and reporting agency. Their Fisker Karma locked up in gear on them during the receiving test, and the dealer had to send a flatbed to get the car. They said it's the first time they bought a car that didn't make it through the initial survey, inputting the car into the system. And so it was a huge blemish for Fisker, which has had a lot of problems. This is a company that has delayed the introduction of their car for years, finally rolled it out in 2011. They have produced 238 of them, have had 2 recalls, and finally shut down their assembly line. Lost their government funding for not making the milestones, and now Consumer Reports is very publicly had a failure of the car. The car, when you get done with the electric drive portion of it and get into the hybrid mode, gets about 20 miles a gallon. It's not even green. It's over $100,000. There's gaps in the body panels, and reportedly the whole dash simply goes dark while you're driving down the road at 75 miles an hour. The headlights and the dash simply turn off. And then we'll come back up and go through the boot sequence while you're going down the road. A very alarming state of affairs. This car is way not ready for prime time, and as we've said any number of times, The Walking Dead. One of the ones that I think probably has their head on their shoulders better than most OEMs is Ford Motor Company. They had a rising stock price through all this, didn't take a government bailout. Announced the Focus Electric, which sounded very good, one of the highest range cars available. But they sold 7 of them in December, 3 of them in January, 0 of them in February, and they're now talking rather vaguely about their availability in New Jersey, New York, and California. So that one's kind of out in limbo. The most curious is, of course, the Nissan Leaf. Carlos Ghosn's bet on the Nissan Leaf is certainly courageous. I think well-intended, well-placed. I think he understands the issues and wants us to get to electric cars and sees Nissan as being the leader in that. They have devoted $1.7 billion to an expansion of a plant very nearby here in Smyrna, Tennessee, about 25 miles southeast of Nashville. They're building a 1.3 million square foot battery plant there. They're doubling the number of employees to 6,000 this year, including 1,300 for the Nissan Leaf specifically and the battery plant. By the end of this year, they will be able to produce 200,000 Leafs a year, and the battery packs for 150,000 Leafs per year. In February, Nissan sold 478 Leafs. And so this is where we're at in mid-March of 2012 with the OEM situation with the electric cars. It is chaos. It's shaping up, as I predicted 18 months ago, to be a bloodbath of epic proportions with surreal, absolutely surreal responses from the automotive manufacturers to this, and without any apparent cognizance of the drivers of what is going to be required to adopt electric drive vehicles in the United States. Electric drive is 8 times more efficient in the use of energy than an internal combustion engine. That's simply a fact, and from that fact derive all the benefits of electric drive. Electricity, unlike oil, is not actually a source of energy. People get confused about this. It is an energy medium, a transport medium for energy. You can make electricity out of anything. It is our most fungible form of energy, in that you can make it pedaling a bicycle with the proper generator. You can make it by falling water. Hydroelectric dams have been around. It was our first generator in Niagara Falls of any size in the United States. You can use photovoltaic panels to make electricity. You can burn coal. You can burn natural gas. You can burn oil. You can burn gasoline. You can burn wood. You can burn corn silage. You can burn ethanol. You can burn just about anything to produce heat, which can then be used to drive a turbine and turn a shaft and generate electricity. And so that's the distribution system. We already have one for electricity. So in changing from gasoline to any other form, it's the only other distribution system we have already in place. We have a distribution system for electricity. It's extremely minor modifications to get that to work. But the magic is in the car. The batteries can only store the equivalent of about 3/4 of a gallon of gasoline right now in energy. So they're not a great way of doing it, but they're much better than they were. We have crossed a threshold of viability, making the car possible. And the drivetrain itself, the electric motor, which is 100 years old, is realistically really 7 to 8 times more efficient at converting energy into forward motion than an internal combustion engine, and always was. And so when we look to the future with a constrained sources of energy, the ability to use the same energy but get 8 times more work out of it by switching our technology a little bit is enormously attractive. Now, the introduction of any technology is really an anthropological issue. It has to do with economics and people and their expectations and their acculturation. And that is what's going to have to be addressed. And the quickest and the easiest one is the basic inherent process that individuals, not states, not central planning agencies, but individuals can be counted on to act in their own self-interest in any economic situation with amazing accuracy and really with quite a almost immediate consensus. And what you're seeing is a consensus that the value proposition presented by Nissan, Chevrolet, Porsche, BMW, and everyone introducing electric drive vehicles is a poor value proposition. That does not mean that electric cars are a poor value proposition. It means that their first attempts at finding gold in them thar hills has been judged by the public as unacceptable. And this is amazing because we have kind of a group of people, my viewers, by the way, almost by definition, who don't care about the value proposition very much. They build their own electric cars. They'll buy about anything anybody builds. They believe in the process so fervently that they're immune to the economic proposition. And so they are, in fact, the leaders of this movement, demonstrating and charging into the acculturation issues in spite of the economics. And so you're all my heroes in that. But ultimately, we need to address the economics. The economics are not something I've spent any time with because they're not anything I personally have a great deal of control over, and I already know how it comes out. It's a numbers game. If you make 100 motors, here's the cost. If you make 1,000 motors, here's the cost. If you make 10,000 motors, here's the cost. If you make 100,000 motors, here's the cost. In fact, you can have any cost you want. Give me a number. And so that's the issue. The automotive companies are acting like victims of the battery situation, yet here is Nissan building a battery plant. And so if you're all hoping for enormous profit margins and a boom from electric cars, it's going to be hard to do that with the competition of a 100-year-old established, competitive, very competitive internal combustion engine automotive market. And so in order to crack that, you're going to have to get your head outside the box a little bit. And I would suggest to General Motors that the money that they've spent on press releases regarding the Volt could have brought the price of the Volt down to that of the Cruise. And had they offered the two cars, which are essentially the same car, but one with electric drive and very advanced hybrid technology in it, that had they offered them at the same price, they would have a growing base of people buying the Volt. And the loss on the Volt would be steadily diminishing. And so as they sold more of them and gained economies of scale across the board, the losses would diminish until at some point you get into a profit situation. Asking them to invest in the future that way is not something I'm either comfortable doing or not doing. I'm explaining that that's what it would take to make the value proposition a go. Whether they choose to do that or not is entirely them acting in their best economic interest. Where do they want to be as a player in that space 5 years from now and 10 years from now and so forth? And so that's the thing. I suppose if you don't ask, you don't get. You can always put together a car, put it out there at $44,000, and if people storm it and 250,000 of them buy it the first year, cool. And that didn't happen. They're selling 500 or 600 a month at the time that they're selling 25,000 Chevy Cruises. And similarly with the Nissan, the Fiskars and the Kodas and so forth, they illustrate a separate thing, and that is just how hard it is to get a thing going with a new car. One of our EVCon attendees came all the way from Lisbon, Portugal, to the United States to go to our convention and spent the week with us. A delightful young man named Kelso Manea. We quite were taken with him, and he showed us some very interesting videos while he was here of his work on a team in Portugal, and it has been an area of interest that we haven't been able to talk about because they were planning actually a production launch of this vehicle. It's a three-wheel reverse trike. Now recall that I was very taken with the future vehicle technology. It was originally future fuel vapor technologies. They changed their name to future vehicle technologies, and they had a reverse trike called the Evaro in the Progressive X Prize. And this vehicle was quite a contender. It actually failed the emissions test. It was a hybrid at a time when it didn't even need the engine to do the competition. But historically it had had one and it applied that way, and so it had to go through emissions test, and it failed the emissions test and so lost the X Prize. I have prevailed upon these people for 2 years to come out with this little reverse trike and this body as a kit, and they just refuse to. They're sure they're going to go into production any minute as soon as Mr. Angel Investor, who is already talking to them, it's secret, but they can't say anything, but is already speaking to them about how they're going to bring $1 billion to them to fund the introduction of this vehicle. It's not ever going to happen. And so now they have devolved to, at this point, a completely moribund project where they do have a grant from the local university to study how to take heat and use it to perform air conditioning work in a vehicle. Sad tale, but I like the efficiencies of a tricycle format. For one thing, it's a motorcycle and avoids many of the regulatory issues here in the United States of a vehicle. There is an issue with reverse trikes, and that is that they tend to have all the weight on the back end where the drive wheel is, including the driver, the motor, the transmission, everything. And so the front end gets to be light, and as they go around the corner, they tend to pick up the wheel on the inside of the turn into the air and not be very stable. One of the more interesting versions of that is the Morgan, a UK reverse trike dating back nearly 100 years. Now in a reproduction, and let's put up a photograph of this. It's really quite an interesting looking vehicle. But they address this weight issue by putting a V-twin engine on the very nose of the vehicle. And that worked it out a little bit. Kelso Manaya has managed to solve this in a much easier way that's available to us in an electric car. And Kelso's job, of course, is the batteries in this thing. And indeed, he has placed the batteries in the very front. Let's take a look at the, what's he call it, the Vika Casino RT, and he sent us a little clip of that. very cool. Last year, would you believe we gave away $20,000 worth of EV components? We held the contest. We got some vendors to help us, Soliton, NetGain. We coughed for, I think about $12,000 worth at the time of China Aviation Lithium Battery Company cells, like 50 180 amp hour cells. And there was an air conditioning compressor from Mastercraft, and a recharge car chipped in, a tachometer pickup, and so we held the contest. 950 people wrote basically an essay of what they would do with these components and what kind of build they would make. And our viewers then voted for them. And the gentleman getting the most number of votes was Brandon Hollinger of Lancaster, Pennsylvania. Brandon is kind of a fine arts kind of guy, a musician, to tell you the truth, in a theatrical group up there in Lancaster for some time. Did a Saab, a 1970s Saab vehicle conversion using lead-acid batteries. That's really quite a gorgeous vehicle. I shudder to think of the weight he's hauling, but it operates very well. He moved on from that and did 2 Miatas, I believe, in lithium cells, and as was awarded at our EVCon convention, the grand prize of all these components. We shipped them to him. He upgraded the 9-inch motor to the 11, is using the Soliton and the 50 cells, and is actually doing a build with a very interesting and unusual vehicle, a 1971 Austin FX4. The Austin FX you'll probably recognize more as the London Taxi, and it actually has a smaller turning radius, I didn't know this, than a Ford Mustang, and it's in a kind of an elegant sedan, suitable as a limousine, basically. And he's going to build this, renovate it, and use it for limousine services in Lancaster, which will render a car that's totally silent, no fumes, and available for weddings. And so I think it's a marvelous thing, because it will expose a lot of people to the experience of riding in an electric car, if only for a trip to the church for their nuptials, and then perhaps to the center for the refreshments afterwards. And so he's does quite a job with the video camera. Let's take a look at the latest installment of Brandon Hollinger's update on the Austin FX4.
So the conversion of the London Taxi continues. One nice thing about this project is I can now run around collecting parts and materials using the electric Saab and not burning up gas and oil in the process. I've also been using it to jumpstart regular cars recently, which is just kind of weird. In the news. A couple of Wednesdays ago, this appeared in our morning newspaper. Good news for EV drivers. And we all know what's happening in the other world. These graphs are actually from about the same period too. I'm just going to leave that up there for a little while longer. And now, a Ford Mustang with a 5.0-liter V8 engine. Through conversation with several mechanics, I decided to use the transmission usually paired with this engine, the T5. From what I've learned, it sounds like this will be a good match for the Taxi and the Warp 11 motor. I eventually found one online at a decent price, which required my dad and I to take a short trip to West Virginia. Apparently, not many people have used this transmission in conversions, so I had to actually mail the bell housing, flywheel, and some measurements to the folks in California that would be fabricating the motor adapter. While waiting for that, I've continued to remove stuff from the taxi. I've also been thinking a little bit about weight distribution.
And that was because you pulled me up. I got up. In a little while you pulled me up. Cast a shadow on the living room wall. Dark and savage with a profile so sharp. Deep and wonderful food on the table. There's really no hurry, I'll eat in a while. I was complaining, I was down in the dumps. I felt so strong, I thought you pulled me up, pulled me up, 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 up. I slipped and I got pulled up. I tripped and then you pulled me up. I slipped and I got pulled up. I slipped and then you pulled me up, pull me up, pull me up. Watch out! Pull me up.
My current plan is to put 28 lithium cells in the engine compartment and 22 in and below the trunk. Allowing for half-inch insulation, I threw together a quick model of the front battery box.
Show what a little faith can do. I was complaining, I was down in the dumps. I felt so strong now 'cause you pulled me up.
Having lightweight models of some of the larger conversion components makes planning a little easier. You can check things like hood clearance and see quickly how much space you have left for other components. Now, if only I had something about the same size as the motor, but weighed about 230 pounds less. Hey, wait.
I got pulled up. I slipped, and then you pulled me up, pulled me up, pulled me up. Pulled me up.
Good. It looks like we'll have decent access to the low voltage terminals and room for the fittings and hoses required to water cool the motor controller.
I think of things that I might be. I see my name go down in history. I was complaining, I was down in the dumps. I feel so strong.
My friend John Yecker, who some of you met at EVCon, runs an automotive air conditioning business and will be installing the AC system for the car. We did some planning and evaluated the space we had to work with.
Pulled up, I tripped, and then you pulled me up. I tripped, and I got pulled up.
I had wanted to find out the ratio of the rear differential, so John was kind enough to push the car while I clung to it and counted revolutions.
Brandon is my hero. This has worked out very well for us with the contest in that we can follow his build probably for most of this year, and hopefully get him to bring the car out for the Electric Vehicle Conversion Convention, September 26th to the 30th here in Cape Girardeau. This is kind of going to shape up as an annual pilgrimage to the EVTV location to see where we shoot the show and build the vehicles and participate in some fun play day events. We're going to have autocross and quarter-mile drag race and maybe a enduro and so forth, and a big vendor floor on the at the Show Me Center Arena, some classes on building cars and some of the issues around the batteries and the controllers and the motors and so forth. And that went very, very well for the 140 people that showed up in September. If they'll each come back and bring somebody, I think we'll be twice as large. And I'm hoping for a little bump on that yet from there. But I would sure like to put Brandon's Austin FX1 on display to show you all what the results of the contest were. I'm kind of trying to reassemble our test bench for the Cadillac Escalade. There are a lot of issues on the Escalade. I'm on uncertain ground. This, for example, is the throttle body. From this, we've removed the plate. I have a 6-pin connector here. 2 of the pins are actually for the motor that positions this plate. One of them is a 5-volt pin. One of them is a return. And that leaves 2 resistor pins that are the signal, the throttle position signal, which is a 0 to 5 volt signal. I believe that one of them goes from 0 to 5 volts and the other one goes from 5 volts to 0, and that the motor works all that out. This is a 5-volt pot from Revolve that we were going to hook up to the butterfly valve. I've pretty much decided not to. We have adequate documentation on these signals. We're going to pick them off and try to see if we can use those as the throttle input signal to the Soliton 1 without disrupting that engine control unit. If we can't, it's probably a matter of putting in an opto isolation circuit to not load it, and again do the same thing, steal the signal and send it to the Solitons. Our basic configuration for the motor drive is the EVnetics Soliton 1 controller in duplicate. We're going to use 2 of them. We have 2 motors on a single shaft. There was some talk with Seb about replacing these with one of their new Shiva high power controllers, which would offer some advantage. The Shiva will do 400 volts at 1,000 amps. 3,000 amps for 1.2 megawatts of power. And that's kind of derated from what it'll really do. It'll really do, those IGBTs will do up to 4,800 amps. And they can let you do that if you need to. And they're positioning that as a racing device. I think it's the King of the Hill mark at this point. Kind of closing out the Zilla as being the top drag racing device. But 3,000 amps at 400 volts is an absolutely ridiculous amount of power, 1.2 megawatts of power. It will instantly destroy any drivetrain, melt any motor. It's $9,500, which I think is out of our range for this application. And I don't think it offers a whole lot of advantage other than it might look really sexy under the hood, would probably make EVnetics look very good. If they want to send us one, we'll do it. But in actually designing this, I like the symmetry of having two controllers and two motors separately driven, almost as a redundant backup. And each of these can do 1,000 amps, and we're going to have a 190 volt pack. And so that's, in theory, 190 kilowatts per motor. In practice, that we will probably know from using 1,000 amp soliton on the Speedster Redux. We happen to know how these cells are going to react. And they're going to react at 1,000 amps by dropping to 147 volts in the case of the Speedster Redux. I would predict these 400 amp hour cells may be slightly stiffer. There might just be a little gain on size to where I would hope to see 150 volts at 1,000 amps per motor. And so with each of them putting out 1,000 amps, we're probably going to depress that voltage further from those cells. But the reason I make this and think we're going to stay at 150 is we were working from 180 amp hour cells, and now we need two of those, or 360 amp hours to maintain 147 volts, but we have 400 amp hour cells. So I'm hoping for 150 volts and 2,000 amps being what our batteries can do and deliver. And that would be 300 kilowatts. 300 kilowatts is divided by 746 watts per horsepower works out to right at 400 horsepower, which is coincidentally the horsepower of the internal combustion engine that we pulled out of the vehicle. In general, if I can replace a horsepower with a half horsepower electric, I'll like the feel. And if I can replace a horsepower of ICE with a full horsepower of electric, I'll like the feel real good. And so we probably have a little bit more than we need to drive this vehicle here. I'm not sure we couldn't drive it with an 11-inch motor and a soliton because of the leverage of retaining the 6-speed automatic transmission. And so with some gearing choices and a 6 speeds to pick from, a hydraulic drive system, I'm confident we could drive that vehicle, and I would be happy with its driving with one of these motors and one of these controllers. However, overkill is always appropriate as a demonstration. This one should drive it at the same rate that it's accustomed to being driven, and that's a 0 to 60 of 7.5 seconds. Now with this weight of batteries, that's hardly possible. But with the same electric horsepower as internal combustion horsepower and that additional weight, I'd say it'll be pretty close. I bet we can do a 9.5 second 0 to 60 with this system and not burn anything up too badly. I really don't want to run 2,000 amps very much through this system. I want to be able to for a few seconds. And I think that in running the two motors and the two controllers, I have a little redundancy there, and I have a little less strain on either controller and either motor. I'm kind of derating this drivetrain by doubling up on what I'm putting through it. The Soliton 1 we selected over a year ago. It's a good unit. We liked it then. I haven't done anything with one for some time until yesterday. And I went and got the new manual. And I went and got the new software. And I have to tell you, I'm blown away by this system one more time. It has gotten better and better, along with the usual growing pains, almost comically, that you encounter in developing product. But they have incorporated, apparently they watch our TV show. I mean, they have incorporated so many things that we do that it's now so easy for us to do using this that it's ridiculous. For example, I've been talking about our meter, our JLD 404AH meter, and these little alarms. They're just little relays. Well, the Soliton 1 has inputs that have advanced way beyond what they were doing last year. And one of them is a percentage of throttle input that I can either apply a ground. I can simply switch a ground to one of these inputs, or a 12-volt signal to one of these inputs using that meter. And it will reset the controller to put out a certain percentage of the throttle, and I can define that in the software. So what does that mean? The daughter mode that I was struggling with, these little resistors and stuff under the dash, is all history. I simply hook up one of those alarm relays to the input of these controllers and tell it, I want, when this is present, when the signal is present, for you to limit this controller to 22.5% of your normal output power. Done. I have 2 alarms on the meter. I can set a second level and a second input and say, okay, now limit it to 5% of your available power, or disable it completely. Let's use it as a brake input, set it to 0%, or define it as a brake input, and where it will never do it at all. You can use one of the inputs with your brake lights, where if you touch your brakes, it simply disables the controller. That's another level of safety. The controller already has 2 ANA 200 contactors inside of it. And so that's a safety item. And so these inputs are really quite flexible and have become quite the thing. What else did I like about this that I found very unusual? Well, the software update, I thought I would just try it. It has a little program called Uploader that Cure or Martin did, and the new 1.51 version, and you simply plug a cable into here. And without specifying anything about the Ethernet, without telling it anything, I applied power to the Soliton and clicked on the Windows program Uploader, and it told me it found the device. It gave me a progress bar and told me it had successfully updated the software. And when I went and checked that in the browser, indeed it had. Now that's pretty good. Let's flip through the owner's manual. There was something else that just blew me away about this controller before we get to the part of really what makes it different from the other ones, which is the idle ability. But there was something that, it'll come to me. Reverse tachometer, brake input. Well, it has outputs as well, and they are essentially little sort of crude PWMs. They chop 60 hertz signal into like 2% per hertz on a kind of a rough PWM output for an output signal, and they're programmable. And so you can use those to drive different things. One of them that they have an output now is for the coolant pump. This is fascinating, and I had suggested it when they first came out with this. They have a fan that they turn on and off with the cooling, and as necessary. I said, why don't you bring that out as an output, and so we can use it to run the pump as well. And it has built-in liquid cooling ports, a little 1/8 27 thread NPTs, and you just take little Summit things and hook up your hoses to it, and it'll do that. But now we have an output that you can use to run, to energize the pump, and so when you're not hot, you're not running the pump, and when you are on demand, it'll turn on the pump and cool itself. I just think that's a tremendous thing. Let's see, what else did I find in here? Yeah, the throttle limit input is just too precious. I mean, you can do that with your battery management systems or with anything. You have a reverse input that you can limit it when you're in reverse, for example. You know, the most interesting one in some ways is the start input. The start input is, we have a start button here. And that allows your Soliton 1, as long as it has a tachometer input, to act a little bit like starting an internal combustion engine with an automatic transmission. And that is that it will ramp up to idle RPMs and then maintain that from there on. We have the manual for version 1.4, and we did the 1.5.1 upgrade. And I had quite a difficulty, and always do have, getting the tachometer to work. And this is one thing I don't like about the Soliton 1. All of the inputs generally require, and all of the outputs generally require additional circuitry. Now that makes it fairly flexible, but it is terribly awkward. For example, the tachometer, I need really a 2.5K resistor. I used a 1K and it worked fine. Between the throttle input and my 12 volts as a pull-up resistor. I've got to put that in my wiring here and under some heat shrink and stuff, soldered together. It's like a hidden component. If somebody came in and tried to rewire this and didn't know what that was and didn't include that, then the device doesn't work, the vehicle doesn't work. And it's not a very easy to label component. There's no place for it, really. Putting them on the terminal board would be more visible, but there's not much room there. And this has to be guarded from moisture and vibration and so forth. So it's a little bit awkward to deal with that. But we did get the tachometer input, and so we can make this work. The other thing I like very much about this, and they have changed it. Recall that I had told you all several times that there is one mistake that almost everyone makes in configuring their controllers, and I have no idea how many cars are out there working at half what they could be doing. And with owners who are vaguely satisfied and have no idea what they're missing. And it's the most common mistake done with controllers, and that is to set a lower voltage limit value. And I don't know why these guys insist on doing this, but every controller I've seen has this. And that is, since they monitor the battery voltage, they feel obligated to guard it somehow. And so they have a value where if the battery voltage goes below a certain value, they will limit the output and so not kill the battery. Most people don't realize how much the batteries go down in voltage when delivering current anyway. I very cavalierly just told you I've got a 190 volt pack. I'm hoping it maintains 150 volts at 1,000 amps. And it's a 1,700 pound battery pack. This is the largest 76 kilowatt power pack I've ever put in a vehicle. And I'm praying that it hangs on to 150 volts. If I had this voltage set at 160, what would happen is the controller, since it operates, in this case, at 8 or 14,000 times per second, it can do things much faster than we can imagine them. And so when it gets down to the 160 volt level, it simply cuts back the current. Well, when it cuts back the current, that takes the pressure off the batteries and the voltage rises. So then it can apply more current. And so what it does is winds up effectively holding it right at this cutoff value. And that limits the power output. Had I simply said, okay, I don't care what you do, I'm going to set the value at 100 volts, so then I can get the full 1,000 amps. The battery pack sags to 147 volts. The controller takes no action, and I'm screaming down the road. So ask me how I know about all this. I made this mistake on our first car, and it drove fine. I thought I was in the cotton. Yeah, I was a little, vaguely, well, these electric cars are, they're not really what I had been told, but it's kind of like a golf cart, but it's okay. And the car was driving. When I made this change, all of a sudden the car almost goes through the fence at my house. It's like getting away from me. A completely different beast. And I've repeated this a number of times with a number of people who have come back and said, Jack, I can't believe it. You just mentioned that on the show. I went out and I had the same problem, and as soon as I did it, this is like a brand new car. I want 5 of these cars now. This is great. And so it's a common thing. The Soliton, what they've done is they won't give it up, but they have split it up. And so now you define 2 voltages. One is the voltage at rest, below which it will not operate. And the other is the voltage under load. Well, that is kind of interesting, because I do know, for example, if I had a 190 volt pack, that, well, let's see here. If I do the math, it's pretty easy to work out. I don't really statically want to go below about 3 volts. And so let's use our magic thing here. 190 divided by 3.35. Yeah, that's 57 cells. 57 times 3. If I set that at 171 volts, then I can disable the controller, essentially, when the batteries get down to, let's say, 170 or 168 volts, and prevent damage to the vehicle. It's not going to drive, and that's the ultimate daughter mode. Not a bad idea. And then a separate level, instead of 170 or 168, let's set it for 120 volts, since I know it's going to sag to 147 for when it's under load. And since the controller knows whether it's driving or not, and it's also monitoring the voltage, it was an easy thing in software to do to have two levels. It can check the battery voltage, but it can test that against two states, driving and not driving. And if you're at a static state and still below this 170 volt. So I actually like that, and we may test that and see how effective that is. But that's another new feature in the 1.51 release. The one feature I didn't like was now when you press the start button, it doesn't start. We'll turn on our electronics. I'm going to leave my blowers off for right now. And let's see if we can get any of this to work. I'm going to turn on my power to the Silicon ones through a contactor. Apply my ignition voltage to it. And they're kind of cycling. And I press the start button. And my arrow lights go out and they're operating, but it doesn't bring them up. If I bring up a little bit of, here I'm at, coming up on a volt, and we're turning up. I'm at 275 RPM. I bring that on up to about 600, and then I'm going to turn it down. And guess what? We pick it up, and it's showing 425 RPM. I have it set at a idle RPM of 500, and we're idling fine. But the start button didn't work. I emailed Seb about this last night, and he assured me that I had something messed up, but then he came back with another email, said he went out and checked it on the 911, and they had somehow disabled the feature in this 1.51 release. New version to come. And so hopefully they'll have that fixed in a software update where I can start it with the start button. The reason I want that, and they feel it's slightly dangerous, I don't, is that I want it to work just like an ordinary Cadillac Escalade. And we're going to use the key and the signal to the starter motor as our start signal. And I want it to bring up my motor and get that reluctor ring turning and notifying my ECU that I'm running. And then I'll release the key just like I normally do, and it'll be on, and we'll have our 12 volt ignition there. But see what's rattling around here. Yep, no, it's running very, very smoothly. And our little logger shows our time, our CPU at 47%, and our amps at 88, 139 volts. I can take my little fluke meter here and cycle that, zero it out. I have about 91 and a half on that one. $85 and a half on that one. And so they're close. They're not exactly identical. Now again, our motor cooling is done by blower. And we're going to suffer a little bit of noise from these blowers, but they're absolutely critical in driving the car that we have them because they cool those motors. It's not such a big deal. In here, I can turn them off and we'll be all right at idling along, but I would not want to do much with those motors. But this is running very smoothly. I've got my tachometer input from the Cherry that Brian put, and we're operating very nicely. Again, I like the new features of the Soliton 1. This has progressed very nicely in a year. And as I said, the comical aspects of product development, they just did a new release in March and somehow dropped the start feature from the mix. And that's almost a whoops and recompile type fix. I'm sure there's nothing in there that precludes their having it. It was just some sort of a switch. And so that should be fixed pretty quickly. And our little front end thing is running very smoothly with our belt and our pump. Something's rattling here a little bit, but not too badly. And you can see our reluctor ring spinning, and our air conditioner, of course, over here. Now this is our connector for that. We'll use the engine control unit and environmentals will still signal this compressor just as it always did to engage the clutch here to actually turn the compressor. We're not turning the compressor right now. We're just turning the idling ring here. There's no load on this. The Soliton uniquely, and as the only controller I know of that has this feature, that does this idle, has a little PID control loop that integrates control of the idle RPM. Now, if our environmental system sends a signal to that compressor for the air conditioner and turns it on, its load on those two motors will go up 5 horsepower probably. It's a big load, and that'll load it down. But the Solitons, and I'm going to have them both. I've decided to have them both idling and actually set up identically. So if one fails or motor fails, that I might be able to limp home on the other one. They can take up the slack in the using that PID loop to maintain the idle. Now we have a very interesting thing going on here. These PIDs, although they're set up identical, are kind of a random process. They're going to come up with different values instantaneously, and they're both driving the same shaft ultimately. There's not really two motors fighting themselves. That's not really what's going on. But we can have uneven loads as far as which one's providing what percentage of muscle. They're kind of like batteries in parallel. These are motors in series in a way, but they're actually wired in parallel. And so it should work just fine. But I'm very impressed right now with how quiet the idle is. I don't have it set up very high, but I can turn this up and do a higher idle. I can simulate that just with the throttle pot I have here. Let's see. There's 675, 680. This is a normal idle. Well, that's 7. There I am at 660. That would be a good idle speed. Although I'm going to try to get away with this 500, which renders I'm seeing 425 to 450, and it's very comfortable. If that'll keep that transmission pumped up and keep that air conditioning going and my power steering and brakes, that's what we'll be at. I think with two motors like that, I can idle at that low in RPM and have enough torque there to be able to keep everything going. With one motor, I'd have to be up at 600 or 700, but I might actually be able to idle there at 400. And so that's what we're looking at for now, is operating two solitons, two motors, using our throttle position sensor from the cable system that connects to here. We found the drawing. We know what pins are which, and simply stealing that signal to use as a throttle. We have our tack signal from our Cherry system now to our solitons, and we've got the software upgraded. We're going to have to upgrade it again to get that start signal working, but my sense is all this is working very nicely to suit. A power test, I don't care. They're going to put out 1,000 amps or not. Once we get the vehicle all put together and I go to moving it, I'll be able to measure that pretty easily. So why bother on the bench and try to tear it up and kill all of us? I'm really after my control signals and my wiring, and does everything work with the software? And at this point, I don't care too much about the power. We do have a situation here that we have learned from John Hall and Tom Bunka at Hellwig about simply seating our brushes. And this is a very nice way to do that with this test bench. I can just turn this on and walk away and leave it idling for the rest of the day and do that 3 or 4 days. And we have seated in the brushes, and that should dramatically lower the noise impact and get all that working pretty well. And so we'll probably just let that run for a while to see what that looks like. To make sure those brushes are seated, we did put the Hellwig split top brushes in both these motors, and so that should make them seat very nicely and be able to handle actually quite higher voltages than we're doing. We used to say 170 volts on a motor like this without arcing too badly. Now with the Hellwigs, we think we can do 220, something like that. We'll be starting at 190 and dropping from there, and I think that'll work very well. So these aren't high HV motors. They're the normal net gain 11-inch. They've been beefed up a little bit by Jim Husted and painted nicely, and the Hellwig brushes installed, and some little adapters we've done to put the blowers on them, but they're going to be black and silver, and I think they'll look great in that engine compartment. They're almost perfectly the right length and should mate to that transmission well, and from there it's a matter of working off some of the sensor issues and the OBD2 issues with the car. And generally I always see much darker things there than what we actually encounter. In almost every case when we actually got down to it, it worked great right out of the box and had a couple of anomalies. For example, the Mini Cooper power steering won't come on until 600 RPM, and it's a manual transmission. We don't have 600 RPM. That's about what we've got to show for this week. Hopefully Brian will be back next week. We'll get a little bit more done, and we'll go forward from there.